What we want to look at now is some specifics about a couple of the notes and just some general structural elements that are going on here and how they work. Again, down here on the C4 column designation, it says that it should be a 4x4 wood column right here with a Simpson standoff base. What I want to do is kind of look at what they're talking about and just talk a little bit about these different connectors. This is strongtie.com. It's Simpson Strong Tie's website, and that's kind of the industry standard when it comes to structural ties for wood construction. They do some for other things too, but it's basically just wood is what they're known for. And there's other types, but this is the industry standard that everybody goes by. It's a good site. They tell you all about their products, what they have. You might want to explore it because there's a lot to it. You can see over here they have load tables and images and all sorts of things you can get from them. But I wanted to kind of focus in on what they're talking about with a standoff. You can see right here we're talking about standoff post bases. There's different types, but this is a basic one. What it is, it's just this little metal base, and you can't see it real well. We'll see it in a little more detail in just a second. Actually, we'll go ahead and look at this one. There's holes in the bottom of the base for the anchor bolts to go through. And so what happens is you could put anchor bolts in the concrete. They would stick up through these little holes right here, put the nuts on them, anchor it down, and then this plate right here is actually what the post sits on. And then nails or screws are put in through these holes in the side to hold the post, such as this right here. There's the plate, the post base, and it's called a standoff because the post is standing off of the concrete, because you got to have room to anchor, put the anchor bolts in, put the nuts on. So you got the flat plate, post sits on it, nails or screws are put in from the side, and then this of course comes up to encapsulate the front of it. So when you're done, this is pretty much what you have. These other images are just different types. This is a different type of base, kind of the same thing for most of these. This one's a little bit different. You can see it's got a slot going through the middle for the anchor bolt. The plate's made a little different, and they're made different for different size posts, different applications, things like that. But this is pretty much what it's talking about. And in a structural environment, the engineer or somebody, but most of the time the engineer would have to specify at some point what type of connector this is, what the actual product number is, and usually that's, if it's not on the plan, it's going to be in the specification book. So somewhere it would have to be specified that, hey, these are the type of standoff bases we're using for our posts, and that would have to be checked on the job site to make sure that they're being adhered to. But they give you all sorts of tables about how much weight can it hold, what size post you would need to hold certain weights, all sorts of information on this particular website. You get PDF files, and you can see different cities have specifications that are different than other places. And if you wonder why Los Angeles and state of Florida, well, Florida, obviously hurricanes are a big problem there all the time during the season, because they're just a big peninsula sticking out there, so they have a little stricter codes. In Los Angeles, we have a lot of seismic earthquake problems, so there's a lot of ties for that as well. CAD drawings, you can download all these different connectors so you can specify them on a plan and actually show them as they should be, and not just make up something. And that's a great thing. And you can actually, somewhere, I don't remember exactly where, but you can actually order a CD that has all their products on it, and it's free. They'll send it to you. But this right here, step-by-step installation instructions about the particular tie or particular base, links to all those things we just looked at, tons and tons and tons of information on here. But again, you kind of need to at some point get familiar with some of these, and we'll talk about a few of them as we go through. But I just wanted to kind of introduce you to the site, what exactly we were talking about when we said standoff post base, and then show you all the information that you can actually get on this particular site. Alright, the last thing I wanted to look at in the sense of this foundation plan and these things we've added to it are shear walls. We've seen this is the detail for how we're going to construct the ones on this particular plan. We've seen where they look, where they are, what they look like. We just have, of course, dimensions coming off slab edges to place the walls. But what I want to do is look at just a few images that kind of depict why we're doing what we're doing. This is an image, very basic image of a little shear wall and how it works, the whole point of it. The point is that we have this wall that's kind of, you can see there's double studs here, double studs there. It's a little 4-foot section. And they have these special connectors on the corners, and we're going to look at those in just a second. But what the whole point is that if this frame is framed like it should be, doubles on the outside, double at the top, these special connectors on the corners, and plywood over it, like we looked at on our detail, then when a lateral load hits it, like a wind force, for us it'd be wind off of a hurricane, say, then it's going to have pressure, compression coming down and tension going up. It's trying to pull it up from this direction and press it down in this direction from this lateral wind load. And so what it's going to try to do is rock that wall. Well, the whole point of all these connectors and the plywood is to keep that wall intact so it doesn't just fold over and collapse like a bunch of dominoes. So that's kind of the point of the shear wall and why we're doing it. This is a pretty good shot of a base plate, seal plate on a wall. That's a hold down. That's a corner, what we call a corner hold down. And a lot of times on shear walls, you'll have these, and even in some cases, if it's not a shear wall, you'll still have these, and you have to have them on the coast because of wind loads. What we do is we beef up the corner with 3 studs instead of 2, and then we have these hold downs, these large ties. In the bottom of it, you can't see it, but there's an anchor bolt going through the bottom of it down into the concrete, and then inside of this plate, there's a bunch of nails or screws coming through there. So that's the hold down. They're going deep into this. So that is a strengthened corner connection. And then here we have some of these little straps. These are more ties, going back to the Simpson website, talking about all the different ties you can get. In this case, you can see there's one on each set of studs that you see. And what happens is these are actually either embedded into the concrete before it dries or tied down themselves with some sort of metal connector underneath the studs. Most of the time they're just embedded in the concrete, and then after you get the wall in place, anchor bolts in place, put the nut on, put the plate on, anchor the wall down, these are folded up and nailed in to add even more support from uplift from the wind or whatever it is trying to pull that wall up. Those are all meant to, again, hold it down, which obviously is where the name came from for this. It's a hold down for the corner. This is a pretty good example, and you can't read the notes, but you can see the picture well enough. This is an example of a shear wall as it should be constructed. Again, corner hold downs right here. Every 4 feet, we got double studs. Actually, most time for us, we have triple studs on the actual corners. Double studs about every 4 feet. And then we get to the other corner, another hold down. And then in between, we have varying sizes of anchor bolts. And the spacing and the size of the anchor bolts is going to depend on where you build and what they say the wind loads are for that particular area. But most of the time there's more than normal, what we consider normal. And then, of course, the plywood sheathing, a lot of times it's at the very least, 1/2 inch, most of the time 5/8, something like that. And then on each perimeter of it, like we said on the detail on the plans, usually about every 2 inches you're going to have a nail, and then a minimum every 6 for the interiors. So there's a ton of nails in this thing. So by the time you do both sides of that wall with all those nails, with that thick plywood, plus all the anchor bolts and the hold downs and the double studs and all this, you've got a really strong wall. And so the point is, again, when that lateral load hits it, you've got so much reinforcement that this wall hopefully will not totally give. It might slide a little bit, it might buckle a little bit, but we want it to stay where it's supposed to be for the most part. And it's wood, yes, but with all of that wood put together like that, it's very, very strong. And so battling all these forces, it does a really, really good job. This is just a different example of a shear wall. Instead of putting plywood all over this, they've actually taken and made it almost like a truss. Run these 2x elements back and forth, zigzagging it, put vertical reinforcement in between those, and then put these big tooth plates on each connection, just like you would a truss. That's a very, very, very sturdy shear wall right there. Even though it's not covered in anything, because of what it's built with, it's really, really strong. And depending on the structure, if it's trying to guard against wind, how it's trying to guard against earthquakes, how large it is, how tall it is, all these different things, how much weight it's holding up, they'll have to be engineered in different ways. But that's a brief overview of shear walls, how they work, how they're built, and what the point is.